Okay, so as I mentioned, today we are going to be going through how to actually calculate the confidence intervals that we talked about last time when we were looking at what a confidence interval is, point estimations and interval estimations, and how is it that we can actually determine how confident we are in a particular interval estimation. So just to kind of recap what we talked about last time, confidence intervals are often used when you're looking at applying the psychology that you've learned about. So again, in a real world situation like a monkey sanctuary that has had to quarantine its infant monkeys separate from its adult monkeys, they need to know how long do the monkeys spend with the terry cloth mother, so that they can buy enough terry cloth mothers for this emergency without breaking their budget. So whereas a psychologist would just be interested, is there a difference, which is what a hypothesis test is for, in the real world, somebody might be interested in what is the amount, how long will they spend with the terry cloth mother, which is what a confidence interval is for. And again, in studies of memory, it is interesting and important psychologically that your memories can change depending upon how a question is phrased. So that is very interesting and sheds light on exactly how memories work in our mind. However, in the real world, they might not want to know just that memory can change, but they'll also want to know how much will the memory change. So if something happens in a courtroom where a question is asked incorrectly, and we know that the memory of the witness has been changed, it's not enough to just know that it's been changed. We might want to know how much more miles per hour did she misremember because of the way that the question was asked. And then also we saw that timeout can be effective in adults, and people are more accurate in the 10-second timeout condition than in the 5-second timeout condition. Again, very interestingly, psychologically, to a researcher, to a theorist. But in the real world, for the very big corporation of America, they need to know how much more accurate. Because if they're going to implement this procedure, if they're going to take advantage of that knowledge that psychologists have discovered, they need to know not just that there is a difference, but they need to know how much of a difference is there. And that's what confidence levels are for. So we're going to go through how to calculate confidence levels today. And we're going to have a little bit of a Wizard of Oz moment, because you have been calculating confidence intervals a little bit in your homework, and I think maybe in your pre-test and post-test. And I'm going to help you calculate them today. And unfortunately, you're going to find out that you've been calculating them all along. You've always had the power, to get back home. So forgive me, I believe it's important to introduce things one point at a time, but I always found that a little annoying that she could have went home that whole time, but no, she had to go on that great adventure. So we've been on the same sort of journey, so now it's time to make it back to Kansas and learn how to calculate those confidence intervals. So we're going to have a very quick overview of what it is that we're actually calculating. Then we're going to go to SPSS and calculate confidence intervals for every situation that we've encountered so far in hypothesis tests, and we'll end it with a little bit of in-class practice. And I'll talk about the homework assignment. All right, so quick overview of confidence intervals. Confidence intervals consist of a point estimate and an interval built around that point estimate. So there's two parts to a confidence interval. And when we report a confidence interval, typically we do it in the form of center plus or minus the interval. So you'll often hear this in political polls. You'll often hear things where they say, well, the approval rate was 58% plus or minus 2.5%. So that's a confidence interval that they're giving you, and we want to do that as well. We want to be able to report it in a way that intuitively makes sense for people. And the way to do that is to report your point estimate, your center of your confidence interval, then plus or minus however long the arms are of your interval. And as we saw, if you choose the interval to be as wide as the body of your distribution, so if your body of your distribution is 90% of the distribution and the tails of your distribution are only 10% of your distribution, then if your sample happens to come from the body of the distribution, you don't know if it does, but if it happens to come from the body of the distribution, your interval will contain the population parameter that you're trying to estimate. And we know that 90% of the samples are going to come from the body of the distribution if we choose to put 90% of that distribution in that body. So we don't know if we're dealing with a sample that comes from the body of the distribution when we're looking at one sample, but 90% of the samples do, so we will be 90% sure, i.e. 90% confident, that our interval contains that population parameter. And it's only when we get unlucky and our sample happens to come from the tail that our interval is going to miss that population parameter. And we control how often this happens by controlling the size of the tails. So if the tails are 10% of the distribution, then the chances that our sample comes from the tails is 10%, which means that we have a 10% chance of missing the interval, the parameter, or we have a 90% chance of estimating the parameter. And we saw that there was, this is based on the formula for the t-statistic. So the t-statistic is the sample mean minus the population mean, all divided by the estimated standard error. And if you isolate for the population mean, you get the population mean equals your sample mean plus or minus your t-statistic times your estimated standard error. So that's that estimate plus or minus a range that we were talking about. And again, we saw that the thing that you want to estimate, your unknown population mean, your best guess is your sample mean, that's your point estimate, and then plus or minus an interval that is determined by the critical t-statistic multiplied by the estimated standard error, the standard deviation of your comparison distribution. All right, so that was my very, very quick recap. What we're going to do now is we're going to do some in-class practice. So if you haven't already, please open the Excel sheet number 29, practice November 29th, confidence intervals. As well, if you haven't, and that applies to me, open up your SPSS. You will have it already installed. I need to go through IU Anywhere, which again is something that you can do at home. And we will get going in just a moment. Nope. All right, so while that's opening, first one that we're going to tackle is going to be the Harlow monkey infant attachment study. So once again, we know that monkeys spend longer with the terry cloth mother. But if we're contacted by the monkey sanctuary and they need to know how long does the monkey spend with the terry cloth mother, how long will this infant monkey spend, so that they can buy enough terry cloth mothers to make sure that every monkey that needs them has a terry cloth mother to access. We need to give them an estimate of how long does each monkey spend with a terry cloth mother. So it's the same situation, it's the same experimental data, but now we're going to use that data to create a confidence interval. So once again, one mother was made of mesh, the other one was had a baby, was made of terry cloth. The mesh one had a baby bottle from which the infant can feed. In a typical day, so this would be the information that we had. In a typical day, the infant spent a total of 18 hours clinging to one of the two mothers. If there was no preference between the two, you would expect the time to be divided evenly with an average of 9 hours for each of the mothers. However, the typical monkey spent around 15 hours per day with the terry cloth mother, indicating a strong preference for the soft, cuddly mother. Suppose that we had a sample of 9 infant monkeys and they averaged 15.3 hours per day with a sum of square deviations of 216 with the terry cloth mother. Is this result sufficient to conclude that the monkeys spent significantly more time with the softer mother than would be expected if there was no preference? These are two tail tests with an alpha of 0.05. We've already done that hypothesis test. We've already seen that they do spend significantly longer with the terry cloth mother. So now we're going to answer how many hours per day do monkeys spend with the terry cloth mother? Now it's important to realize that if they wanted a point estimate, if they wanted our best guess of how many hours per day do monkeys spend with the terry cloth mother, that point estimate would be our sample mean. Because to our best knowledge, monkeys in general will spend 15.3 hours with the terry cloth mother. That's our point estimate. But remember that we have no confidence whatsoever in that point estimate because it's very precise, which means that we have low confidence. So what we need to do is we need to find intervals around that point estimate that give us certain levels of confidence. So we're going to compute a 95% confidence interval. So let's say that one of the workers at the monkey sanctuary said, you know what, I would feel safe and I would feel that these animals are going to be taken care of if I'm 95% sure that we've got enough terry cloth mothers. So calculate a 95% confidence interval. That's what I want to know, how long the monkeys spend with the terry cloth mother. Somebody else might be a little bit more cavalier, right? And might say, you know what, because of the budget, because of our constraints, I'm willing to be a little bit riskier to save a little bit of money. How about just an 80% confidence interval? Let's go with that instead. And somebody else might say, you know what, these monkeys' lives are everything to me and I cannot risk them being, without a terry cloth mother, so I need to be 99% confident. So we're going to see those three confidence intervals computed, and we're going to do it using SPSS. Alrighty, so right now, what we're going to do is we're going to set up our SPSS hypothesis test. This is going to go pretty quick just so that we can fit all three of them in. But the setup for this is the same as the one sample t-test. So Harlow's experiment needs to be analyzed with a one sample t-test. So the initial setup is the same as for a one sample t-test. So here we have the data in Excel. And if you haven't already, follow along. We'll take that. We'll copy it. We're going to paste it into column 1, row 1. So those are the hours that each monkey in our sample of 9 monkeys spent with the terry cloth mother. We go to variable view. We change that var 00001. Let's change it to terry, just to let us remember that that is a terry cloth. And if this was a hypothesis test, we have it set up and entered correctly in SPSS, we would go and do our hypothesis test. This is where that Wizard of Oz moment comes in, because the hypothesis test is exactly where you go to run or calculate the confidence intervals. So we're going to go to Analyze. We're going to go to Compare Means. We're going to go to one sample t-test. So that's how we would have run a t-test in order to test this hypothesis. Same thing, it's the same procedure to run a confidence interval. So we click on that. We send the terry cloth as the test variable. We remember to change the test value from 0 to the hypothesized mean, which is 9 hours. So if there's no preference between the terry cloth mother and the wire mesh mother, these monkeys will spend 18 hours in total with both mothers. And if they don't prefer one over the other, they'll spend 9 hours with one, 9 hours with the other. So if we were just running a hypothesis test, this is where we would hit OK, and we would take a look at our output, and we would decide whether to accept or reject the null hypothesis. Now, however, we are doing a confidence interval. So for that, we have to go to options here. So for the first time, click on options, and you'll see that there's not a lot of options for a hypothesis test for a single sample hypothesis test. And the only option really is what confidence interval percentage do you want? So this is where you set the information for the confidence interval percentage that you want. The default is going to be set to 95%. That is by far your most common confidence interval that people will ask for. So the default is set there. We hit continue. We hit OK. And we get our output. And what I want to draw your attention to is in that one sample t-test, we have this last two columns in that table that say 95% confidence interval of the difference. This is where we're going to find the information that we need in order to finalize our confidence interval. But SPSS has very nicely calculated that 95% confidence interval of the difference. So far, so good? All right. So that's a 95% confidence interval. Remember that we also asked for an 80% confidence interval. So for the 80% confidence interval, we go back to analyze, we go back to compare means, we go back to that one sample t-test. It's all already set up for us. The test value is the correct test value, the null hypothesis test value of 9 hours with each mother. However, now we go to options and we're going to update that 95 and we're going to change that to 80. And that's how you get different intervals. That's how you get those different confidence intervals. So we hit continue, we hit OK, and we have ourselves that 80% confidence interval. And notice that SPSS is being very nice to you because it actually labels your confidence intervals. In case you can't remember which one of these was 80, which one of these was 95, it very nicely just has that information. It says, hey, by the way, this is the 80% confidence interval. Notice that it says confidence interval of the difference. We're going to get to that in just a second. All right, one last time. We have our one sample t-test all set up. We go to analyze, compare means, one sample t-test. It's all set up. It's all ready to go. We go to options. And now for that last person who wanted to be very, very sure, who wanted to get a confidence interval that they could be 99% confident in, we're going to put 99% into that confidence interval percentage, hit continue, hit OK, and we have our 99% confidence interval of the difference. All right. So there's our outputs. And I wish it was just a straightforward read off of SPSS, but we do have to do one more little thing. We do have to apply a little bit of logic to this to get to that point where we say they spend this many hours plus or minus this amount. This is our confidence interval. So anyways, let's zoom in and we'll start off with the 95% confidence interval of the difference. And just because we're doing confidence intervals, you should still make sure that you check, this one sample statistics table up here and make sure that the N, the number of subjects, is correct. So we had 9 monkeys and we should have had 9 monkeys. Make sure that the mean is correct so that you know that you've copied and pasted correctly. The mean in Excel is 15.3. The mean in SPSS is 15.3. So now we have those aspects and we can actually start kind of piecing together our confidence interval. So what's the mean amount of time that monkeys spend with the cherry cloth mother? That is going to equal the sample mean plus or minus the critical T multiplied by the estimated standard error. So if you are doing your homework, and actually no, it's not going to happen, but if you need to know what the estimated standard error is that's being used, that's the estimated standard error right there. So if you need to break down this piece by piece, your mean, in this case, is your sample mean, plus a T statistic multiplied by your estimated standard error, which in this case is 1.73. And then this T statistic is the one that you look up from your T table in order to, to have 95% in the body, 5% in the tails. However, SPSS wouldn't be so useful if it left us that much heavy lifting. So what we're going to see is that SPSS gives us the information for our confidence interval. We just need to work with it a little bit. So there's our degrees of freedom that'll allow you to look up that T critical. But importantly for us, SPSS has given us a 95% confidence interval. The only thing, though, is that it has given us a 95% confidence interval of the difference. And it's this of the difference that you need to be aware of. It's this of the difference that you need to be careful with. And the reason that we have this of the difference is because in this case, SPSS has calculated out not the amount of time that they spend with the terry cloth mother, but how much more time do they spend with the terry cloth mother. So what SPSS has done is it has said, I'm going to tell you how much more time these monkeys spend with the terry cloth mother. And what they do is they spend 6.3 hours more with the terry cloth mother. That is SPSS's point estimate for how long the monkeys spend with the terry cloth mother, 6.3. All right, and then the other thing that it does is it gives you a 95% estimate for the lower and upper bounds of its estimate. So its best guess for how much longer the difference that the monkeys spend with the terry cloth mother is 6.3. The lower bound given to you right there is 2.3 hours. The upper bound given to you right there is 10.29 hours. And that is the 95% confidence interval for the difference. So if that is what our monkey sanctuary wanted, then we would be done. If that is what the monkey sanctuary wanted, if they said, hey, how much more time do the monkeys spend with the terry cloth mother? We would tell them 6.3. That's our best estimate. But notice that's not what they wanted at all. They don't want to know how much more time are they going to spend with the terry cloth mother. They want to know how much time, right? What is the amount of time? And in order to get the amount of time, not the difference, but the amount of time, we need to do a little bit more, a little bit of maneuvering, a little bit of logic. So what are these confidence intervals of that SPSS has given us? Well, they are of the difference. And they are of the difference between how long the actual monkey population spends with the terry cloth mother versus our assumed hypothesized population that spends 9 hours with the terry cloth mother. So this 6.3 hours more with the terry cloth mother is 6.3 hours more than the 9 hours that we thought they might spend with the terry cloth mother. The 9 hours that they would spend with the terry cloth mother if they had no preference. So that is the difference that they're talking about. They're talking about the difference between what we actually found and our hypothesized population. So to get to how long they actually spend with the terry cloth mother and to get it into a format where it's a point estimate plus or minus a certain amount, we need to use a little bit of logic, a little bit of math, and what we need to do is we need to factor back in that test value. So, once more time, they want to know how long do the monkeys spend with the terry cloth mother. SPSS said, well, they spend 6.3 hours more. 6.3 hours more than what? 6.3 hours more than your null hypothesis mean, which is 9. So if they spend 6.3 hours more than 9 hours with the terry cloth mother, then our confidence interval is centered around 15.3. And notice that that is the sample mean. All right, so the best estimate for what does the population mean is always going to be that sample mean. So once again, we get back to 15.3. And now we need to know what is our interval. We need to know what is our confidence interval. And just like we added 9, right, the original hypothesis, null hypothesis, to the best estimate of the difference to get to the actual amount, we can do the same for each of these other bounds. So we're literally taking the entire confidence interval and we're just kind of moving it over and centering it on 15.3. So 9 plus 2.3, we get 11.3. 9 plus 10.29, we get 19.29. And that is the range and the interval of how long will these monkeys spend with the terry cloth mother. And then the last thing that we need to do is we need to, again, put this into a formula or a format that is easily understood by most people, and that is the center of your interval plus or minus how long your arms are. So when we're talking to these monkey sanctuary people, we want to tell them, your monkeys, I am 95% sure that the average time that they're going to spend with the terry cloth mother is 15.3 plus or minus this length right here. And the easiest way to get this, and the way that I like to do it, there's a number of ways to do it, but what I find is the easiest is to go this number minus your center. So go your upper bound minus your center, and it doesn't matter if if both of those are positive, it doesn't matter if both of those are negative, it doesn't matter if this is positive and this is negative, it'll work in every single situation. So we go 19.29 minus 15.3, and that will give us 3.99. Yep, that'll give us 3.99. And this is your final 95% confidence interval. When we call them up and they say, how long do these monkeys spend with the terry cloth mother? I need to be 95% sure. We are going to tell them, oh, they spend 15.3 hours plus or minus 3.99 hours. And that is confidence interval number 1. So again, our assumed population, we hypothesized that monkeys that do not prefer the terry cloth mother will spend 9 hours with each mother. We found that our population belongs to a new group of monkeys that spends longer than 9 hours. The difference between this new population and our old population is that 6.3. That is the estimate of the difference that SPSS gave us. So that means that our new estimate is 15.3. Notice the sample was the best estimate, the point estimate to begin with. And now we get our 95% confidence interval, and we can be 95% confident that the monkeys will spend a maximum of 15.3 plus 3.99 hours. So if you want to make sure that you got enough terry cloth mothers for your monkeys, you want to be 95% sure you buy enough monkeys, enough terry cloth monkeys, so that each monkey has on average 19.29 hours to spend with that terry cloth mother. So that's the way that you would calculate this confidence interval. And if you do this for the 80% confidence interval, you will get a smaller interval. So again, this reinforces the idea that the smaller your interval, the less confident you are. So if you only need to be 80% confident, you can assume that the monkeys will spend at most 15.3 plus 2.42 hours, or 17.7 hours with the terry cloth mothers. But if you want to be 99% sure, then that interval has to go bigger. It's got to cover more of the possibilities. So for a 99% interval, you're looking at 15.3 hours plus or minus 5.81. So you're looking at about 21.1 hours with terry cloth mother at most. All right, so any questions on that so far? All righty, so that was number 1. That was our one sample t-statistic. Now let's move on to our independent means t-statistic. So this is for a confidence interval where the data is coming from an independent means study, where the situation is such that we have 2 different samples and they were each measured once. So again, if we were called in a court case to assess witness testimony, and specifically we're asked to say how much did this witness overestimate how fast the cars were going, how much more speed did she remember because of the way that the lawyer asked the question, that's what we want a confidence interval for. So we've already done the hypothesis test that says, yes, she did increase her estimate. Now we need to know in this real life situation, how much more? How much more did she increase that estimate? All right, so we go back to the Loftus and Palmer study. So their classic study demonstrating how language used to ask a question can influence eyewitness memory. One group was asked about how fast were the cars going when they smashed into each other. Another group was asked the same question, except the verb was changed to hit instead of smashed into. Smashed into group reported significantly higher estimates of speed than the hit group. Suppose a researcher repeats this with a sample of today's college students and gets the following results. So we've already answered, do the results indicate a significantly higher mean for the smashed into group? Yes, they do, with a two-tailed test of an alpha 0.05. But let's say now that we're being asked by the judge in this trial, how much faster are the estimates for the smashed into group? How much of an overestimation is there? And they want us to compute a 95% confidence interval and an 80% confidence interval, and one more time, that 99% confidence interval. All right, so we're going back to SPSS. And again, remember that when you're computing confidence intervals, in order to do it correctly, you have to identify the correct hypothesis test to do. So this is data that is based on two samples. Each sample is treated differently. They're measured only one time. That's an independent means T statistic. So we're going to go back to SPSS, and we're going to do an independent means T statistic. So if you haven't already, start entering in your data into SPSS. Just so I'm not confused, I'm going to close down the output for the previous one sample T statistic, and I'm going to delete this data so it doesn't get in the way. And this is the data that we want for the independent means T test. And much like one of those cooking shows, I've already prepared something in the lower oven. So if you just want to copy and paste that, it's already formatted correctly. So it's beautiful and light and fluffy every single time. All right. So we copy and paste that, formatted correctly. Variable 00002, that's going to be our speed. And the variable that says smashed or hit, that's going to be our group. All right, so we have the smashed group, we have the hit group, we have the speed estimates there. And then again, we've identified this as an independent means t-test. So to calculate the confidence interval, we do the exact same thing. So we go to analyze, we go to compare means, we go to independent samples t-test, and we set it up as if we're running a hypothesis test. So we click on that. The test variables, those are the raw scores, those are the speed scores. The group variables go into the grouping variable. Sorry, the grouping variable is where we define the name of the groups. We have to tell SPSS what those groups are. So we have smashed as one group, we have hit as the other group. And if we were running a hypothesis test, this is where we would hit OK and we would interpret our results. However, now we're doing confidence intervals. So once again, we got to go up here to options. And we click on options, and lo and behold, once again, not that many options. Basically, what confidence interval do you want? Confidence interval by default is going to be set to 95. So always double check that, because it will carry over if you're doing the same t-test over and over again. It will remember the last one that you had. So always double check. We got 95%. We hit continue. We hit OK. And SPSS, if you see those last two columns there, has very nicely given us a 95% confidence interval of the difference. We were asked for two more confidence intervals. So the next one is an 80%. So once again, analyze, compare means, independent sample t-test, just like a hypothesis test. It's all still set up. That's the nice thing about running confidence intervals back to back to back. But now in the options, we change that 95 to 80 because we want an 80% confidence interval. We hit continue, we hit OK, and it's calculated that 80% confidence interval, once again, of the difference. Right? So we got an 80% confidence interval of the difference. SPSS is very nice to label as confidence intervals and let you know exactly what it is you're looking at. And then finally, we need a 99% confidence interval. So we hit once more our independent samples t-test. We go to options. Notice that it is now at 80 because that's the last confidence interval we asked for. So we got to update that to 99. And we hit OK. And we hit OK again, and it runs it. And we have our 99% confidence interval of the difference. All right. Let me get rid of this because we're going to use the same sort of structure. This is the same procedure for just about every single confidence interval once you get to this point here. All right. So back to our SPSS output. All right, so there's the SPSS output, and let's zoom in. And this time we're going to zoom in on the 99% confidence interval. And notice again, it's of the difference. So as always, double check your size of your sample, double check the mean of your samples. Just make sure that you haven't missed any data or entered it in incorrectly. For the confidence intervals that we're looking at, once again, we're going to stick to that equal variance is assumed. So that top row in the second table, we're only going to be dealing with that top row. For the degrees of freedom, that's the degrees of freedom. If you need to figure out the critical T value, if you're doing this by hand, that's where you can get the degrees of freedom to figure out the critical T value. That's the estimated standard difference. So again, if you're doing that formula where it equals your sample mean plus your T statistic multiplied by your estimated standard error, that's your degrees of freedom to go to your table and look up your T statistic. That's your estimated standard error for that value right there. But again, we're going to let SPSS do all that heavy lifting. And what we're going to be looking at is that 99% confidence interval of the difference. So in this case, it's a little bit easier because this time SPSS has calculated the 99% confidence interval of the difference. And the judge that called us as an expert witness wants to know the estimate of the difference. So this one is a little bit more straightforward. So always when you're doing a confidence interval, ask yourself before you start doing these final calculations, ask yourself if the person or the confidence interval has to be for a total amount. So for the monkey confidence interval, how many hours do they spend with a terry cloth mother? In that case, you have to add back in the hypothesized mean. On the other hand, if they're asking for a difference, right? So in this case, the judge is saying, how much did she overestimate her testimony? How many more miles per hour did she remember the car going? That's a difference. So if they're asking for a difference, as they are in this situation, it's a little bit more straightforward because that is what SPSS will give you. So our best estimate for the difference, how much faster did she remember the car going? According to the data that we're working with, that mean difference is 6.8 miles per hour. So if we just gave one number, if they just wanted one estimate, that would be the mean difference. That would be the difference between our two samples. And that point estimate is 6.8. Now we want a confidence interval, but it's important to remember that point estimate is the center of our interval. So that's going to be, once we're done our analysis, 6.8 plus or minus some interval. So where do we get that interval? Well, SPSS has very nicely calculated the lower and upper bounds for our confidence interval. So the upper bound for the confidence interval, let's start with that, is 14.06 miles per hour. So she might have gone as high as 14.06 miles over, right? She might have estimated by as high as 14 miles an hour. The lower bound, on the other hand, and this is a highly interesting case, is minus 0.46 miles per hour. And what that means is that she actually might have underestimated by about half a mile per hour, right? So our interval, in order to get 99% confidence, is so wide that it actually contains the possibility of an underestimation. However, be that as it may, we still need to get this plus or minus part of it. And again, the easiest thing to do is to go to that 14.06, go to that upper bound. Well, I mean, it's easy because I've practiced it this way. But one of the ways that you can do it, that'll work every single time, take the upper bound and subtract from it the middle. So the middle of the interval. So 14.06 minus 6.8, and we're going to get 7.26, I think. Maybe we'll know on the next slide. All right, but anyways, this is what you're looking for this plus or minus, because confidence intervals are symmetrical, right? The size of one arm is the size of the other arm. You figure out one side, you figured out both sides. All right, so that gives us that 6.8 plus or minus 7.26. Yeah, that's right. Okay, so we used some logic, we used some math. We finally got it down into this formula over here. So again, the key here is to, again, figure out, were they asking for the difference or were they asking for the whole amount? In this case, they were asking for the difference. How much more was her speed estimate? So in that case, our best guess, our center of our confidence interval is that 6.8, that mean difference. And we take our upper and lower bounds, upper bound minus the middle, and we find our plus or minus value for our confidence interval, which in this case is 7.26. All right, so this one is actually pretty interesting, because if you were in a court of law, this is how this might occur. Here's the no difference line. And the no difference line is what would be, is the place where she crosses from underestimating to overestimating. So this side is underestimating, this side is overestimating, and if she crosses this no difference line, if her estimate is on this no difference line, that means that she may have accurately remembered how fast the car was going, regardless of how the question was asked. So if the judge in this courtroom says, you've been called as an expert witness, what's your estimate? The witness gave their testimony. The question was asked in a way that, could cause problems. What's your estimate for how much faster she remembered the car's going? What's your estimate for how much she overestimated that speed? And you would say, well, my best guess is 6.8. 6.8 is my point estimate. Are you confident in that? No, I'm not. Not whatsoever. I have no confidence. I got high precision, but I got no confidence. And if one of the lawyers says, well, give us a 95% confidence interval. And he said, all right, if you want to be 95% confident, 6.8 plus or minus 5.35 miles per hour. And notice that entire confidence interval is in the overestimated side of this slide over here. So again, this is overestimation, this is getting it right, this is underestimation. So the entire 95% confidence interval, you can be 95% confident that she overestimated her testimony. And it could have gone as high as 12.15 miles an hour. But definitely it was overestimated. If, on the other hand, the other lawyer says, objection, objection, we don't need 95% confidence. Where I come from, country lawyer myself, we only need 80%. All right, fine. 80% confidence, 6.8 plus or minus 3.41. If at that point the judge steps in and says for testimony to be admitted as evidence, it needs to be 99% confident or more. And that's typical for any sort of forensic evidence. That's actually, if my years of watching Law and Order is correct and years of watching Maury Povich's You're the Father things are correct, you need to be 99% sure in your results. So if the judge says, give me a 99% confidence interval, you would say, all right, I am 99% confident that her estimates were overestimated anywhere up to 6.8 plus 7.26, which is 14.06. However, notice that the lower bound of that estimate, of that confidence interval, crosses the no difference. So what this means is that this 99% confidence interval contains the possibility that her estimate is correct or underestimated. So if the judge then tells you, asks you, are you 95% confident that she overestimated her testimony? You can say, yeah, 99% confident her recollection was overestimated. If they go, are you 80% confident? You can say, yeah, 80% confident her recollection was overestimated. But if they say, are you 99% confident that she overestimated her testimony, at that point you would have to say, no, I cannot say that I am 99% confident because the 99% confidence interval contains no overestimation and a little bit of underestimation. So you could not be 99% confident that an overestimation was made. All right, so that's the independent means t-test. We got one last one to do, and that is for the dependent means t-test. So once again, we go back to our timeout situation. And once again, it's enough for us as psychologists, and it's enough for me as a researcher to know that there is a difference in the accuracy as you increase the length of the timeout from 5 seconds to 10 seconds. But if a corporation wanted to take advantage of that to increase the accuracy of their workforce, they would need to know how much more accurate before they can make that kind of a financial decision. So they might call you up as a psychologist and say, we've read this very interesting study. We know that they're more accurate in the 10-second condition. Tell me, how much more accurate are they? We need an actual number, an estimate of the increase in accuracy that we can expect. So again, notice, not asking how accurate they are, asking what's the increase in accuracy we can expect. So once again, we would base this confidence interval on the data that we previously analyzed. So we have an experiment that we analyzed where one group of people were measured on a task when they were punished with a 5-second timeout for every wrong answer, and the same group of people were measured on a task when they were punished with a 10-second timeout for each incorrect answer. One group of subjects measured twice. That's a dependent means t-statistic. So we know that they're more accurate in the 10-second timeout condition. We've run that t-statistic. What we want to know now is how much more accurate were they in that 10-second timeout condition. So what is the difference? How much more? What's the increase in accuracy for that 10-second timeout condition? Compute a 95% confidence interval, 80% confidence interval, and a 99% confidence interval. So I keep choosing those because those are the most common ones that people usually ask for. But you can literally go into SPSS and do anything from 1% to 99%. I don't know who would ask for a 5% confidence interval, but the ability is there. All right, so back to SPSS. And what we're going to do is we're going to take our data for question number 3 here. And this is the 5-second condition. This is the 10-second condition. And we're going to set it up to do our last confidence intervals, which is basically, again, the setup for a dependent means t-test. So I'm going to get rid of these so that we're not confused. And once again, we know how to set up a dependent means t-test. We know that each subject gets their own row for all of their data. And we know that we cannot start this off with 5. So we're going to call this second 5 for the 5-second condition and second 10 for the 10-second condition. And we have our dependent means data properly formatted for that dependent means t-test. Once again, to calculate the confidence interval, we go to Analyze, we go to Compare Means, we go to Paired Samples t-test. So remember that the dependent means t-test in SPSS is run under that Paired Samples t-test option. We click on that, and we want to know how much more accurate is the 5-second condition than the 10-second condition. So we're going to take the 10 seconds, we're going to take 5 seconds, we're going to pop that in as variable number 1. We're going to take 10 seconds, we're going to pop that in as variable number 2. So you can see it right there. And now we got to do our confidence intervals, and we got to do our options. So we go to options, and notice again, default set to 95%. So we got that all set to go. We hit continue, we hit OK. And we have our 95% confidence interval of the difference. Now this is an excellent case of what I was talking about before when I was talking about getting your orders correct. So I put in 5 seconds and then I put in 10 seconds. And SPSS took the 5-second condition minus the 10-second condition, and it's given us a mean difference of minus 7%. You can see it right there. That mean difference of minus 7% means that the 10-second timeout condition is minus 7% worse than the 5-second timeout condition. All right, so minus 7% worse is plus 7% better. So I can manipulate this, and I can say, all right, minus 7% worse is plus 7% better. Okay, that makes sense. And a lower bound of minus 11.61, if it's a lower bound of minus 11.61 worse, is going to be an upper bound of 11.61 better. If you're fine with that, do it. I'm not going to do that. So I'm going to close this. As soon as I see this, as soon as I see this nightmare of negatives up here, I'm going to say to myself, you know what? Thanks, but no thanks. Let's close this. Let's close this output. And I'm just going to go back to Analyze, Compare Means, Paired Samples t-test. And it's already set up. And I'm going to go to where my variables are. Let me stretch that out a little bit. So, whoops. Let me stretch that out a bit so everybody can see. I'm going to go where my variables are, and I'm going to switch them. I put 5 seconds first. I put 10 seconds later. It led to this negative nightmare of logical gymnastics. I don't want to have to deal with that, so I just went back here. I switched to 2 of them. I hit OK. And now look what we have. We have the 10-second timeout condition is 7% better, right? Positive 7%. We have the upper bound and the lower bounds nicely in the positive. So again, it's just a way of getting rid of those mental gymnastics if you don't want to have to jump through those hoops. All right, so now that we got it all set up correct, we got an 80%, we got a 95% confidence interval. We have to do an 80%. So once again, back to Analyze, back to Compare Means, Paired Samples t-test. Keep it set up the way that we got it, because we got it set up correctly now. But we go to Options, and instead of 95%, we're going to change that to 80. Hit Continue. Hit OK. And SPSS has calculated an 80% confidence interval of the difference. And then finally, we need a 99% confidence interval of the difference. So Compare Means, Paired Samples t-test. Once again, it's set up, and that's a nice thing. It carries over this setup, so you don't have to redo it all the time, but we do have to go to Options and update that confidence interval, this time to a 99% confidence interval. We hit Continue, we hit OK, And SPSS has calculated 99% confidence interval of the difference. All right, let's wrap this up. So we have our confidence interval of the difference. We're going to take a look at the 95% confidence interval here. So let's zoom in on that. And once again, it's the same idea. It's the same structure here. So again, the question to ask ourselves before we start messing with anything here is, do we want the whole amount or do we want the difference? So this company did not ask us, how accurate are they in the 10-second timeout condition? They asked us, how much more accurate are they in the 10-second timeout condition? So because of that, because SPSS reports the interval of the difference, we can do that. Oh, and I actually have my mental gymnastics there. Clearly, I was feeling better when I put this together. Okay, so sorry about that. I'll do the mental gymnastics. You follow along on yours. The key thing here, though, is once again it'll tell you which one it is. You're going to have time 10 minus time 5. It gives you the standard error of the mean. That is this part of your confidence interval equation. It gives you the degrees of freedom. That allows you to look up this part of your confidence interval equation. However, we're going to let SPSS do all the heavy lifting. So again, we want a difference. SPSS is reporting a difference. Makes it a little bit more straightforward. So we got a little bit of light on this board here. So we have our point estimate, and the point estimate is going to be the mean difference between our two samples. That point estimate is 7%. So our best guess for how much more accurate is the 10-second condition is going to be 7%. We then go to this confidence interval of the difference, and it gives us our upper and lower bounds. Now you have it in the mentally friendly version. I got to do a little bit of flipping, but if you read, your upper bound should be 11.61, and your lower bound should be 2.387, so 2.39. That's your upper and lower bound. So we can be 95% confident that they're going to see an increase of at least 2.9%. And they might see an increase as high as 11.6%. So once again, we got to finish this off by saying center point estimate, 7.0%, plus or minus, what's this distance here? You take your upper bound, subtract away your middle portion. We, in this case, get 4.61. And even in this nightmare of a confidence interval output where everything is negative, if you take that upper value and you subtract away this mean, you will still get 4.61. It works every single time. All right, so we used our logic, we used our math, we put it into the formulation that people can understand using the mean difference and those upper and lower bounds. And now we have our 95%, 80%, and 99% confidence interval. So once again, our best guess, our point estimate, is our mean difference, that 7.0. So if they just wanted to know how much more can we expect, what's the increase in accuracy, we'd be in that board meeting and we'd say 7%. You guys can expect 7% increase in accuracy. But if somebody said, hey, you know what? I need to be 95% confident. You know, I've got some of my own money invested in here, and I want to make sure that I don't lose it. I need to be 95% confident. What's your range? You would say, all right, well, I can be 95% confident that it's anywhere between 7.0 plus or minus 4.61. So you can expect an increase up to 11.61, but at the least, you can be 95% confident you're at least going to see a 2.39% increase in the accuracy. If somebody else in the board meeting says, you know what, I got none of my money tied up in this company, so I don't really care if we go belly up. I just need to be 80% confident. What's your 80% confidence interval? You would tell them, all right, it's 7% plus or minus 2.79. So again, notice smaller confidence, lower confidence, smaller confidence interval. And then finally, if there's one last person in that boardroom and they say, you know what, I borrowed money from the wrong people and my legs are going to be broken if this does not work out, I got to be 99% confident before I risk this money. You can tell that individual, all right, you can be 99% sure that you're going to see an increase in accuracy of 7% plus or minus 6.71. So anywhere up to 13.71%, but at least 0.29%. So you can, in this case, be 99% confident that you will see an increase in accuracy, because notice it did not cross that no difference line. All right, that was a lot of confidence intervals going on. So before we wrap it up, just want to mention for the homework assignment for number 13, homework assignment number 13, it's not a MyLab homework assignment. It's an Excel homework assignment. It's an Excel sheet. The assignment can be found in homework assignment number 13, confidence intervals. That's in the Canvas folder. That is the Excel worksheets. And I will bring it up real quickly, just so you know what you're looking for. So this is the Excel sheet that you're going to be looking for. And the Excel sheet is going to work a lot like a MyLab assignment. So you have your answer, and a lot like an exam. So you have your answer cells right there. So let me zoom in on that. So what I'm looking for is, number one, I'm looking for your point estimate. So your best single number that indicates what is your best estimate for whatever their question they're asking. And then you're going to be asked for two confidence intervals, either a 99 and an 80, 80 and a 95, whatever it is that they ask. And I want that point estimate plus or minus some range. So use SPSS to calculate the point estimate, use SPSS to calculate the range. Ask yourself, do they want a difference or do they want a whole amount when you're working on your homework here? One thing to keep in mind is that your point estimate is always the center of your interval. So this point estimate, your best guess, is going to be the center of your interval. So you should see the same number in all of these cells. So don't think that you're doing something wrong or that I couldn't possibly ask for the same number 3 times. It should be the same number in all 3 of those cells. And then the other thing that I just want everybody to be aware of is that this homework assignment is self-grading, and you can actually scroll down here and it has the answer key underneath, much like a fully graded exam. It's got the answer key underneath. So you can attempt this as many times as you want before you upload it for your homework points. So do this as many times as you want until you get 100%. If you do this first question, for example, and you scroll down here and it's all X's, go back up, try it again, try to figure out what went wrong, give it another try, and feel free to do that until you get all of these correct and until you're getting 20 out of 20 on each question. So feel free to do these as many times as you want, and then submit your completed Excel sheet to Canvas, much like you would an exam. And then that I mentioned, and then we ran out of time for in-class practice right now, but if you do want to give these a whirl, there are a few more demo questions. The data is in the Excel sheet that we were working on today, and this might help you for your homework. The descriptions are in SPSS, and not only are the descriptions in there, the data is in the Excel sheet, but it also gives you the answers in terms of what the confidence intervals are that you should be coming up with. So give these a shot. If you try your homework and you just can't figure out what's going on, give these a shot. Give them a try, and maybe that will give you a little bit of extra practice and help you figure out what is going on. All right, other than that, that is all that I wanted to cover today. So we got about 6 minutes left. So if you have 6 minutes of questions, feel free to put up your hand and let me know, but otherwise feel free to call it an early day. And again, make sure that you're looking for that homework assignment in Canvas. It's not in my lab. And try it as many times as you want to get full points before you upload it. But just make sure it's uploaded before the due date. I believe it's December 3rd at midnight. All right, that's it for today. Thank you very much, and I will see you all next time.